All right, welcome, ladies and gentlemen. My name is Brian McLogan, and this is week 13 open Q&A. Here I am, here to answer your questions and hopefully help you guys out with your math as we get going into working with distance learning. However, I have been going live since the beginning of this year to really just kind of help questions and really just kind of interact with you guys on a little bit different level. But obviously things have changed a lot in the last couple weeks. And so therefore I just wanted to make sure that I was there for you guys to answer any questions or to help you guys get along. I know that not everybody has, videos or anything else that they're looking for. So I just want to make sure that I'm available to answer questions for you guys as they come up. But obviously, guys, I'm not able to answer every single question that I obviously get asked, as I do receive quite a bit of questions on Instagram and Messenger and through Discord and on the community post. But I really, really do appreciate them. And thank you so much for sending them over. I did go ahead and get some questions in here. So we're going to go ahead and solve with some right triangles. We're going to multiply some binomials. Somebody just asked me to talk about my favorite and least favorite math class. So I was like, I'll do something a little bit different. I'm going to do like a summary of sine, cosine, and tangent. We're going to solve a linear equation. And then I decided to kind of at least show my work. I'm not doing everything, but I'm at least going to go ahead and show the work for a word problem that was basically presented to me. So I'll kind of, that's what I'm basically going to explain here for this live stream. And then obviously, if we finish a little bit earlier and we have a little extra time, then I will be more than happy to answer some additional questions. So if you guys do have some questions in there, feel free to add them into the chat. And if I can't answer them, hopefully somebody else in the chat can. But I do see John, Abdeli, Yuli, Eduardo, Keen, Pianos, Daniel. Thank you so much, guys, for joining in. And a couple quick things that I did want to let you guys know of that I am doing a little bit differently for up there. So if you guys, for those of you that maybe you're checking into this live stream for the first time, just to kind of let you guys know that all these questions have been pre-submitted. And again, students can go ahead and pre-submit their questions on the community post that I post every single Saturday when I remind you that I'm going live. They also can be, I believe in here, actually, I'm not sure if I have this. I believe also the Discord link is down in there that you could also go ahead and submit your questions. Some of these were from people taking a picture and sending that picture to me on Discord. And that's why I kind of chose Discord as an alternative way for you guys to submit questions. So feel free to go ahead and do them on the Discord, which I have the link in the description. And then also, guys, I am doing an extra bonus live stream on Wednesday just to kind of, make sure, just to let you guys know that I'm available for you guys. So as far as what I'm doing in the class this week is I'm going to give out kind of my first assignment, a assignment that my students are kind of familiar with. And I've already pre-recorded the assignment. So I provide them with the answers and a recording of the answers and everything like that. But basically there's a couple different options for us to be able to submit work. And so we're going to go ahead and try to work on some of that and see how that goes. I'm not really sure how I'm going to like students submitting work and so on and so forth. But we'll just kind of, we'll go from there. I just wanted to kind of play off some things from there. And I know some of you guys are, maybe depending on your break or based on your school district, you guys are just getting started with this distance learning. And I think really like everybody's kind of in the same, boat. I mean, teachers, parents, students, it's all a big learning curve as far as, being so used to a rhythm and process, and then now having to really finish off this year going through the distance learning. So it's been pretty crazy so far. Hey, Sailing Cam. Hi, Aiden. And Anthony Morgan, I have a word problem. I do not want word problems, Anthony. I try to avoid word problems just like you guys try to avoid word problems. But in reality, it's not so much that I want to avoid them. It's just they're difficult. You know, you can see how much work, like if I was to actually to explain this here, like this just looks like pretty crazy stuff, right? And then if they had a word problem, I'd have to read it, or you guys would have to read it. And it's so in depth for something on these live streams. I just want to get to something very quick and concrete and help you guys out. In the same respect, you know, I typically don't do like summary videos or people want me to talk about certain concepts. But the more specific you guys can get, the more likely I'm going to be able to provide some feedback or at least some talking about whatever you're asking. You know, if you're just, you know, saying explain, you know, trigonometric ratios or whatever, like I spend more than a day talking about that stuff. So I'm not even sure what I should do for, you know, a 2-minute excerpt on that. And I don't really think that's going to give you any value anyway. So the more specific guys you can be with your questions, the more beneficial I think it is for everybody, as well as a little bit easier for me to be able to understand. All right. Oh, well, thank you very much, Mary, for joining in. Teacher, I know it's it's a lot to take on for sure. And I do like the live stream. I will give you a tip. I've made a lot of videos before I even started going live. I started going live maybe like 2 years ago. And even when I first did a live stream, I was nervous. I still get nervous. It's one of those things like getting over that camera and just kind of getting used to the live stream and like, you know, missaying your words and like there's no like stop and re-edits. It's a whole different beast, but I really do enjoy it. And I do think one thing that I do like about the doing a live stream is just the like authenticity. You know, it's just you feel like you're actually like there with the person communicating. And that's why I do like the live stream a little bit element. And that's what I do with my students. I go live with them every single class period. We don't go through like the whole class period, but I do always do a live stream with them. And so therefore we just have that kind of chat. Like I don't teach through the live stream. I do a pre-recorded lesson. So I kind of like flip my classroom. I do a pre-recorded lesson, send them, give them the work. And then my live stream is basically kind of like the office hours, kind of like I'm doing now, just answering questions. As far as the technology I'm using, yeah, Trevor, I got my trombone. I'm not going to show it though this time. I'll keep it down. But as far as the technology, I am using Notability as my whiteboard. That way I can also upload my documents. I'm on a Mac, so I'm using Ecamm, which is only available for a Mac. And that is your software basically from there. So that's what I am using. Nature is awesome. I am doing very well. I did play trombone. No, I'm not going to play my trombone. Maybe one of these days, maybe after we get over like this craziness, I will, I'll break out my trombone, but my lips are not really used to it. So they get like numb really, really quickly. But, and plus I got to like practice the song. It's been, right now I can remember is like the B flat scale. So I'll work something up for you guys. Well, actually probably not. You're probably not going to, well, I don't know. Maybe I'll just turn the audio, but thank you for nobody telling me my audio was all off. I was doing the audio off of my webcam last live stream on Wednesday and it sounded horrible. And then I didn't even notice that. So now I make sure that I checked my audio for that. But yeah, if the audio seems off or not like normal, please let me know because I have no idea how it got changed, but it got changed off of my mic and it was off of the thing. So, thanks, Trevor. Yeah, actually, I got to work on the thing, but actually, I'm even wearing my shirt too because they are really comfortable. I was actually like really, really surprised on the merch how comfortable it is. But I'm even wearing my own little shirt today. All right, guys, let's go ahead and get into these Q&A problems, and then we will. Yeah, and then we'll see if there's any other questions. So if you guys do have some questions or you are just hopping in to the live stream, then please feel free to put a question into the chat. And again, guys, I will kind of see how long these problems take me. And if I can get to your questions by then, I will do that. All right. So first question. Now, again, here's where it kind of gets into the specificity. So in this problem, the student gave me A, B, and C, and they said, we want to know like how to find secant. Now the problem is, or secant of theta. The problem is we don't know where theta is. And that's actually this is like a huge issue at this point. So let's go ahead and look at a triangle. Now, obviously, we know that 26 is going to be the hypotenuse because that's the largest side, right? The other two sides, it doesn't really matter. But let's just make the height 24 and this 10, okay? Now, let's say theta was right here. Okay, now we can go ahead and evaluate our trigonometric functions based on that angle. But our problem is we don't know if that's where theta was supposed to be because we didn't have a picture or the student didn't know where to reference. And that's why it's kind of like really important to understand these trigonometric ratios. They all depend on where the angle is, right? So when we're trying to evaluate the secant of theta, that means that the secant, which is really just a ratio, right? A secant is a way for us to compare. It's a comparison. But it's a comparison of sides of the triangle based on where theta is. So these are completely two different problems. I'm still going to use the same variable theta. But so in this case, if here's theta, remember secant. So actually, let's just do cosine. So cosine of theta, which is typically remembered a little bit easier for students, that is going to be adjacent over hypotenuse. So that's going to be 10 over 26. I'm not going to reduce that. I'm not going to simplify. Well, actually, I can. So, all right, fine. Cosine of theta, then you can reduce, divide by 2. That's going to be 5 over 13, right? Just go ahead and reduce that. I'll just write it like this. Okay. Well, actually, no, let's just leave it like that. I don't want to confuse people. They'll be like, look back at my notes and be like, what happened? So yeah, you can go ahead and reduce that, but we're just going to leave that from there. Now, the secant is just going to be the reciprocal of that. So that's going to be opposite over adjacent. But again, this is all based on where theta is. Here, theta is between the 10 and the 26, right? So here's the hypotenuse and here's the adjacent side. And that's a point I should probably make is remember when you have a triangle, a right triangle, you have the hypotenuse, which is always the largest side. The adjacent side is the side between the angle and the 90 degrees. And the opposite side is the side that is opposite of the triangle. So you can see why 10 for theta over here is going to be the adjacent side and 24 is the opposite. So the secant of theta is opposite over adjacent. All right. Now, however, I didn't know if that's what the triangle looked like or the triangle looked like this. See here, you can see theta is between the 26 and the 24. So now the opposite side of theta here is 10. So the adjacent side is 24 because remember 26 is always going to be there. So again, here we can just say the secant is going to be hypotenuse over adjacent. So to answer the student's question, I don't really know which triangle is there. So therefore I can't tell them what their answer should have been, but I can only say, well, based on where your theta is, these are your two answers that it's going to be. And again, but I think this is really important for everybody to take away from this is your trigonometric ratios, sine, cosine, tangent, tangent, cotangent, or sine, cosine, tangent, cotangent, cosecant, and secant. They depend on the angle. They are a comparison of sides of a triangle based on the angle, where that angle is in the triangle, because you have to understand the hypotenuse, the adjacent, and the opposite side from that angle of the triangle. Okay. All right. So now let's go and talk about multiplication of binomials. Now the student wanted me to go ahead and just multiply binomials, and I could quickly, easily do that. That's not a problem at all. But for some reason, I just kind of thought if they're asking me to multiply binomials, they probably are having a little bit trouble of like, I don't know, maybe an easy way to like remember or to understand what the multiplication of binomials is doing. So if I was going to multiply 3 by 4, I'm just going to do a little bit of elementary here. If I was going to multiply 3 by 4, a lot of times we just do, 3 times 4, and we know the answer is 9, right? Or I'm sorry, no, we don't know the answer is 9. We know the answer is 12. 3 times 4 is going to be 12. All right. Now, some of us just have those multiplications tables memorized. Obviously, I did not. And then sometimes we also have looked at it as far as finding the area, right? Because if I had like a length times width, we know that would give us the area. But sometimes understanding, like, how does area fit in with the multiplication of two numbers? So if I had 3 here, we could call this as 3 rows. And if I have 4 here, we could represent this as 4 columns. Okay, so I have 3 times 4. You could have 3 rows of 4 columns. And what you can see here, I'm not really sure if that even made sense, 3 rows of 4 columns. But you have 3 rows, 4 columns, and what they make is they make up 12 squares. You can even count them. You can see how there's 12 squares. So that's how we can represent here 12 representing the area of some rectangle in units. Now, you could do that exact same thing you could do that exact same thing with the x's, but sometimes it gets a little confusing in that point. So what I'd like to do here is just kind of remind students of like the distributive property. Like when you have a value that's outside of the parentheses, you can just distribute that. So x times x is x squared. X times 1 is just going to be x. Okay, so I'm going to approach this in 2 different ways. So we can do this kind of like geometric visualization way, or we could also just kind of memorize what it means when we have something multiplied outside parentheses. So the first way is just knowing, I'm just going to kind of go back to this parentheses way. Well, I know that this is going to be, if I need to apply distributive property, you need to apply it for both. So therefore, that's what we're going to do. We're just going to multiply 2x times both of these terms. Okay. And then we can multiply the -1 times both of the terms. Okay. And sometimes we can solve this like the FOIL face, or I think I even did the FOIL face upside down. Either way, whatever like kind of trick that you can remember to apply distributive property. But basically, when you have something outside the parentheses, you need to multiply it times every single term inside the parentheses. And obviously those terms need to be separated by addition or subtraction, right? We're not multiplying the 3 and the x, we're just multiplying that by 3x. So you could go ahead and list them out together. But for the sake of time, I'm just going to multiply. So 2x times 4 is going to be 8x. 2x times 3x is going to be a 6x squared. -1 times, let's do top, -1 times 3x is a -3x. And -1 times 4 is a -4. Okay, now we're going to write this in standard form where we're going to have our first degree listed first and then go down in descending order. So we could have a 6x squared. 8x minus 3x is going to be a positive 5x minus 4. And I didn't really do that as well as I would like to. But again, it doesn't really matter if they're not in order. You can just re-put them in order at the end. Now, let's go ahead and just take a look at this way, because some people always get confused or they'll make a mistake. So remember, you can always like fall back on this idea of area, because we know that 3 times 4 represents the area of a rectangle. Now, again, this is confusing though for a lot of students because x is an unknown, right? So what I'm going to do though, if I have 2 terms of this binomial, I'm just going to represent them as 2x and -1. And then over here, I'll represent this as 3x plus 4. Okay. And again, we don't know the value of x, and we're not trying to pretend we know the value of x. We're just using that as a variable, but we know that the product of these two is going to represent the area of this rectangle. Well, now, just like these represent unit boxes, like 1 times 1, here we're just going to find the area of each of these, and then we can add up each of these. Like basically, let me put it this way. This is like 1, 1, 1. This is like 1, 1, 1, 1, right? 3 ones get us 3, 4 ones give us 4. So 1 times 1 is 1. And that's why we added all of those up when we found the area of each of those to give us 12. So here, that's exactly what I'm going to do. 2x times 3x is 6x squared. 2x times 4 is going to be a positive 8x. 3x times -1 is a -3x. And -1 times 4 is a -4. So now you can see that, again, that is our area. And you can see that on the diagonal, those add up to give us a 5x minus 4. Okay, so for simplicity and speed, I would just use the FOIL or distributive property. However, when you sometimes get something that's a little bit more complicated, or if it gets a little messy trying to do that, you can always fall back on using the box method. Cliff, hard math problem. Jeez. Nobody wants to do a hard math problem. Come on. But yeah, Cliff, go ahead and send it to me. Obviously, if it's something a little bit difficult to send to me on the chat, then you could obviously go ahead and send it to me on Discord, which I believe the link is in the description. If it's not, I'll make sure it's added. All right. The next one's asking, what is your favorite and least favorite math class when you were a student? And I don't know. We didn't really we did integrated math. So we didn't take like algebra 1 or geometry or algebra 2. So I'll go ahead and add on that my favorite, or I'll just kind of pretend if I took those classes, or at least maybe that I've even taught. But my favorite would have been geometry. Like when I was in high school, I really liked geometry. I actually liked proofs. I know I'm kind of like weird. But yeah, that was actually, I really enjoyed proofs. I really enjoyed like puzzles and like thinking that way. I did not really enjoy like algebra 2. I don't really like just doing math problems. I know that kind of sounds crazy because I do open Q&As and I just answer your questions. But there's a little bit of an element to that. There's a little variety with that. But as far as just like doing math problems, that's not something that really excites me. And even like, I remember even going like to calculus. I was like, all right, I'm just sick of doing math problems. I like when I was in college, I didn't after I did calculus, it was fine. But after I think I got into like calc, I'm like, all right, I'm just kind of like bored. It's just like boring, just doing math problems. But then once I took like graph theory, one of my favorite class, at least in college, was graph theory. And I just really, really enjoyed writing proofs. I really enjoyed that kind of pure math and really just, thinking about things. That is something I enjoy much more than actually just doing math problems for random sake. So if we're going to say a favorite, let's say geometry. And one that I did not really care for would have been algebra 2. And again, just because algebra 2, I figure like you're just doing math problem, or college algebra was like the same thing. It's just doing math problems like over and over and over again. And you don't really have any, any application to them or, any like how they're connected. It's just like doing math problems. So I think for a lot of students, that's where I was kind of like them. But also I know a lot of students just don't like geometry. They don't like that thinking either. So they don't want to do math problems or thinking or whatever may be the case. But anyways, we can definitely help you find a math for everybody. All right. So least favorite. Cool. All right. Let's go and get into the graphing a sine, cosine, tangent summary. So the student asked me to talk about like graphing trigonometric functions. I'm like, all right, well, I spend a whole 90 minutes on that. So what value can I give to you if you need help graphing these 3 functions? And I don't know, they just said trig. So it could have been cosecant, secant, and cotangent, but then it's just getting even more crazy, right? So I'm just going to stick with these 3. I think the main important thing is knowing the parent graph for each of these functions. Because when you're graphing these functions, not the parent graph, the initial period of each of these functions. So the initial period is basically the one period before one period of the graph without any repetitions. And then for tangent, looks something like that. Okay. So I think it's important for you to know what these graphs look like, because then we're going to have different transformations. And these transformations are based on A, B, and C and D. So just remember when you're doing these problems, B times X minus C, A, B, C, and D, they all impact our graphs differently. And again, also, it's kind of important. Oops, I forgot I should use cosine. I should also note that how sine and cosine are so similar to each other, right? They're basically the same graph, just shifted over one, or shifted over pi halves. Need this one. Oh, I did everything in black again. I don't know why I did that. And I don't have time to go over this. Sorry about that. How long? Crap. 15 seconds, that is. I guess I must have accidentally hit my mute button. I'm sorry about that. Did I have, could you guys just let me know? Was that only for the last number that I had there? Thank you so much for spamming. That was crazy. No sound. Thank you so much. I apologize for that. Pretty much the beginning of question number 5, I believe. Right? At least I'd be able to get to this. Do I need to go back over the summary or just a quick one? I need to go back over the summary. Just 5. Okay. I'm just going to stick with 5. Thank you. So I'm just on 5. So what I was doing here was that this problem had way too many fractions. That's what I was saying. And so what I needed to do is eliminate the fractions. I said, well, how am I going to eliminate the fraction? I wanted to find the LCD, or the LCM of my denominators. So what I did was I listed out the multiples of each and every denominator. And what I was doing was I was trying to find the smallest number that they all shared in common. That would be our least common multiple. And I couldn't find one. And obviously you could keep on going on and on and on. But then what I kind of worked into is a trick that you can always do to find a common denominator, or a common multiple is just to multiply them. So I just multiplied 2 times 5 times 3, and that gave me 30. Now, again, that's not always going to be the case. Sometimes they do have a common multiple that is smaller than their product. But in this case, that did not work. So confused on number 2. Well, Ian, if you can ask me a question, I will go back to number 2. So what I did is I just multiplied them, and that gave me 30. Then again, just kind of like I talked about distributive property, I'm going to take 30 and multiply it times every single term. And so 30 times 1/2 x is 15x. 30 times 3/5 is 18. 30 times 4x is 120x. And 30 times negative 2/3 is going to be a negative 20. Okay. So now you can see that I have 120x minus 20x, and those are like terms. So I have 15x plus 18 equals, and that gives me 100x. Then again, now we just really want to work to getting our variable on the same side. So I'm going to subtract a 15x. Oops. Okay, and I get 18 is going to equal a 85x. And then I will just divide by 85 on both sides. Oh, I forgot I have one more question. X equals 18 over 85. And there you go. All right, last question, which is a word problem, which you guys doesn't really make any context or sense to you. But it was one of those problems where it was a word problem, but they didn't have a triangle. So I'd recommend, guys, when you're doing trigonometry, create a triangle. So if you have these word problems, make sure you're drawing a triangle. And if I had more space, I would draw this triangle separately, or at least just kind of like draw both of the smaller and the larger triangle separately so you can understand that. I don't have a calculator with me, nor do I really want to have the time. But basically what I wanted to show the students is when you have two triangles within each other, it's best to kind of redraw both triangles. And therefore you can see that for this angle is 84.2, this side length is x plus 50, right? So if both these triangles have the same height, so I can write a relationship. And that was the first step, the first step was drawing the triangles. Then the next step is creating your trigonometric equations. Now, what they have in common, they do have x in common, but that's a little bit more difficult to set them both equal to x. So what I did is I set them both equal to h, which is their height, and then I set them equal to each other. Now I can go ahead and solve for x, and then hopefully you could plug that into your calculator. You can find x. And then the two questions the student had to figure out was what is h and what is d. So now that you figured out x, now you can just pick one of the triangles, preferably this one, the smaller one, and then to go ahead and solve for h and d. So hopefully that helps you out. I'm not sure how long, not very too long, but I will just kind of go back into the chat and see. I don't always stay on, guys, for so much longer, just because I want to make sure I can get through the questions. But again, guys, I'm live every Sunday night at 9 p.m. as well as on Wednesdays. So at 9 p.m. for as long as this distance learning thing is going on. So if you guys do have questions, always you can add them into my community post, or you can always add them into the Discord link, which I believe is in the description down below that you guys can go ahead and send. Sure, Lucas. I don't have a calculator though, so I'm not going to be able to get you very far, but I can at least explain how to set that one up. And I'm not sure you didn't use parentheses, so I'm assuming the -3 is down there. Okay. Hey, Justin, thanks for copying my code. Hey, thanks for copying. What? I don't know what you guys doing. Oh. How long can I ask questions for? I will be here throughout the year. You're very happy, Justin, and Matthew. I'll be here, guys, for the rest of the year. But yeah, again, every Sunday and Wednesday, guys, I will be going live. So if you have questions, make sure you guys bring them to me. And YL, thank you. You are very welcome. Question number 1. I was in who commented that question. My professor didn't even give me a picture. He does this on exams on his phone. So he's like, oh, okay. Well, now hopefully my explanation helped you out understanding how important it is to know where your theta is, because you can see that if we don't have the information of where theta is, then there's 2 different answers. So that would have been something that you'd want to make sure that you clarify with him. So therefore, he understands that he did not provide that to you. So I'm confused. Want me to review on question number 2? Well, question number 2, I kind of went into a whole lot, and I don't want to overcomplicate things. And I'm not sure if this was your question that you actually asked. If it is, then I could go into it a little bit more. But my point that I'm trying to bring into is a couple things. One, when you're doing multiplication of two values, that is always actually going to produce an area. Okay, so if I do 3 times 4, some of us just have that multiplied or memorized as 12, right? 3 times 4, we don't think about it, we know it. And I don't really know where you're coming from or what, how old you are, what class you are, or whatever else, but a lot of us just have this memorized by now. For speed, it just makes sense to do that. However, conceptually, it's helpful to understand that 3 times 4 also produces the area of a rectangle, right? So you could do 3 columns and 4 rows. And if you can see, that's going to make 3 units here and 4 units here. And when you multiply the area for each of those little boxes, you get 1 unit box, right? Add all of them up and you see that there are 4 boxes there. So it's good to conceptually understand area or multiplication like that as well. Now, a lot of times though, once we introduce variables, that kind of gets a little confusing to understand that a x can represent the side of a rectangle, right? So that's why a lot of times we just refer to the distributive property. Just make sure you understand that if you have a number outside parentheses, that you multiply that number to both terms outside parentheses. And again, you could do it like this too, like 2 plus 2. 3 times 2 is 6. Plus 3 times 2 is 6, right? 6 plus 6 is 12. So you can see that's how the distributive property works, right? And a lot of times that is helpful. So when we get into teaching binomials, you can see that both this 2x minus 1 is being multiplied by the 3x plus 4. So you need to make sure you multiply every single term times every single term. So that's why I was creating these little lines here to represent everything needs to be multiplied by everything. So that is basically, and people call it FOIL, first, out, inner, last, or you can just call it distributive property, whatever may be the case. But then I also want to say, well, another way you could do it is you could actually go to that idea of that. Sometimes when we do more let's say it was a trinomial times a trinomial, sometimes doing distributive property like that is just going to be very confusing and a lot of work. So that's why I also teach the box method of just understanding that that the product of 2 values is going to create the area of a rectangle. So therefore, just go and take those two sides and use them to represent the lengths of a rectangle, and then just go ahead and multiply to find the area, which would be the area of each of those boxes added up. So hopefully that helps a little bit better. Volume is all the way up. Okay. I don't know. Actually, your streams, I'm from Australia. Online learning is so hard to get used to. Well, yes, I totally agree. It is, and the other thing too is like, nobody has this figured out, right? And I mean, that's like online learning has been around for a long time. There's a lot of people that take online courses. But, and I like record all my lessons, and my students, have access to those, but my students are not required to watch my lessons. But there's also a lot of people that do like flip math, but again, still they have that interaction with this teacher. So nobody is used to this 100%. And so, yeah, there's a big learning curve that, your teachers are going through. Obviously your parents too, is like getting this rhythm and everything else. Like and then also for you guys, like, you having to rely on, what instructional materials you're given, and then also like your limited time, interacting with your teacher, or however may you interact with your teacher. So yeah, I know it's a lot, but I think that as we continue kind of going through this, we will kind of see what works and what are some like best practices. And those are some things we're going to keep on improving upon, right? Because, I'm not used to distance learning. I mean, I make a lot of videos and I go live with my students, but I don't know how they're going to react to certain contact, or how they're going to, what about when I start teaching something that's very, difficult, in my class, and they really need more support. What are some things that I can do in this kind of environment to really help them out? And those are some things that we haven't been able to, haven't had to face yet. So, but that's some things that I'm looking to grow upon and learn from as well. I flip classroom squad. Yeah, Justin, I have a ton of videos on ellipses and everything. If you guys, whatever class you are taking, I've taught algebra 1 through calculus. You guys just go to my playlist tab on my YouTube channel. I mean, I have everything for all of those classes. I have everything kind of broken into and broken down. Now, again, it's not broken up into like, watch this video first and then watch that video, but it does kind of take you into a, whatever types of problems that you are currently learning, you can go and see me solving those types of problems. So that's basically how the channel up to this point has been set up. And it says you can ask any math question. Yes, you can, but I do not have that much time left for me to be answering so many questions. But yeah, I take any question. I can't answer every question. And even some questions that I do answer, or I am able to answer, that's why I say also beginning, like, don't give me word problems. It's just too much time for me to read through it, for me to think through it. I want to make sure for these live streams, guys, to give you as much value as quick as possible. So, and again, if it's something that I'm not like familiar with, or if it's something that I haven't taught in a long time, and I don't think my explanation is going to be on point, then a lot of times too, I'll just say, hey, I'm just not comfortable like explaining it, especially on a live stream. But it really just kind of give you an explanation, something I'd need to like sit down and just like, remember some things, or maybe just check up on some things, make sure that I am remembering everything correctly. And again, on a live stream, I don't really have that time, but either way, that's why I always say, guys, submit your questions ahead of time. So therefore, like the student that submitted the word problem, I had time today. So I went through and did their work for them. But again, I wasn't going to post the question. It was just kind of too much. Ask questions while explaining this. Brian, degree value of cosecant. I don't know, just multiply by pi over 180. I'm not really cosecant. I'm not really sure what your question is really trying to mean from there. I still have some problems through Missable. Well, please send over the questions for me, and I'll be happy to answer everything you guys have. All right. I have a lot of videos on that. How do you find the degree value of cosecant of 54 pi over 11? I'm not sure, but you can convert. You need a calculator for that. Oh, how do you find the degree value? Well, I don't know what you mean to degree value. You're either trying to evaluate the cosecant of an angle, or you're trying to convert 54 pi plus 11, which is in radians, to degrees. So you're trying to convert the angle to degrees, or are you trying to actually evaluate the cosecant of 54 pi over 11? And by the way, if you need to evaluate or just find the value of that, you're going to need to use a calculator, which I do not have. But if you are trying to convert 54 pi over 11 and you want to put that into degrees, see that as a radian. And if you want to make that into degrees, then you're just going to multiply by 180 degrees over pi. And then basically what you do is you just reduce your fraction there. So, and actually I don't know if anything would reduce, but again, I would need a calculator to multiply 54 times 180 and then divide it by 11. Well, hi, Emma. Can you show the formula? I'm not sure what formula you are referring to, Arslan. Oh, as far as converting, there you go. So hopefully that helps. Just make sure though, if you're doing degrees to radians, then it's going to be pi over 180. Right? Because the pi's divide out. So that's why you can see we're going to be in degree form. Could you please give a shout out to amazing Algebra 1 teacher, Miss Milazzo. I think that's right? Well, hi, Miss Milazzo. I think I pronounced your name, and if I didn't, I apologize because I am horrible at pronunciation, but that's okay. I'm going to own it, and everybody else on the live stream gets to obviously see that I'm horrible with pronunciation. But anyways, I hope you are having a great and excellent week doing this distance learning. I know it's a lot of fun figuring out something completely new for all of us, but hopefully that helped. And what up, Mr. Porter? I give you another shout out. I enjoy that your students are reaching out for you, so therefore I can give you a shout out. But hopefully you are having a great time. I think maybe the benefit for us teachers is, there's not as much grading. I don't know. At least I'm not having as much grading from that point. So I guess I'm kind of happy for that. And oh God. Where t is greater than 0. Yes, and obviously all the people, leukemia patients in hospital, you guys are giving me a lot of shout outs from there. But yeah, anybody that is, definitely going through leukemia in the hospitals, geez, the coronavirus, and we got a lot. But yeah, I definitely give you guys for leukemia, shout out. But for those of you guys in leukemia, I really want you guys to, get yourself well and keep those spirits bright and get better for sure. And all right, and then I'll give a shout out to Miss Martin. And Miss Martin, Miss Nork from Texas FSMS, and then Aaron does that equation. I'm not sure how to graph it. That's going to be a little bit too much for me to do at the end. If you want to send that to my Discord though, I'll maybe spend up a little more time to help you out with that. Yeah, I would definitely, as far as a graph like that, I wouldn't be able to give you really anything that's going to look nice from on there. I would just look at, Desmos. Basically the only thing I'd be able to help you out with understanding your transformations from there. But then plus also, I'm not really understanding your question, how you have it. Well, hi, Scully. Thank you very much for the thing. And I'm not sure on your name, but I did ask a question for the function P of t. And I'm not sure what I'm asking, what you want me to do for your function. You just have a function in there. And I will say, though, for your function, I would need a calculator, and I do not have a calculator. But if you want to maybe give me a little bit more context on that, for that function in P of t, like what you're trying to do, then send it to me on Discord and we'll be able to I'll be able to see what I can do. All right, guys. But again, for those of you that are adding into the end of the chat, please make sure, guys, the easiest and easiest way for me to be able to answer your questions is to have them pre-submitted to me either on my community post or in Discord. It just makes my life a lot easier to be able to see what you guys are asking and have time to like digest what you're asking. In the same respect, make sure you guys are specific. Like, what do you want to do? Like, are you solving, evaluating, graphing, just having an equation or a process. I don't know what it is that you are needing help with. And that's what I want to do is I want to provide help. But if you just say like, graph lines, I don't know graphing lines or solving, or if you just say like solve for X, like what type of equation, what are we dealing with? So the more specific you can get, the easier and more likely it is I'm going to be able to answer the question. And then also, please be aware, guys, I do not use a calculator on the live streams, and I kind of do that on purpose to also just, make sure I'm not going to be spending a whole bunch of time, typing in stuff that you guys aren't going to see. So, when we do have problems where a calculator is required, I will do as much as I can do without the calculator. So for instance, I'm assuming the student is asking me to solve for X. So the first thing we want to do when we want to solve an exponential equation is isolate the exponent or isolate this exponent. Now this E is actually in the base. And then it's raised to the 0.6x. So the first thing I'm going to do though, is I'm going to add a 3 to both sides. And then I have 40 E to the 0.6x equals 240. Then I'll divide by 40 on both sides. And then I have E to the 0.6x equals 60. Okay. Now, what do we do from here? Well, now we're going to use the rules of logarithms to take the natural log of both sides. So when I do ln of E 0.6x equals the ln of 60. Now, based on the rules of logarithms, this just leaves us with 0.6x equals ln of 60, and then we'll just divide by 0.6. So therefore, x equals the ln of 60 over 0.6. So there you go, ladies and gentlemen. Unfortunately, that is kind of it for me on the live stream. I know there are some other questions, and I didn't even update everything since I kind of went through the last problem. But I do apologize, guys. I will again be going live on this Wednesday. So if you guys do have any questions that you'd like me to answer, please make sure you guys go ahead and submit them onto the Discord. And I will be more than happy to see what I can do to what I can do to help you out with that. So otherwise, guys, have a great night as well as great week going through this distance learning. And again, if you have more questions, make sure you go ahead and check out my live stream on Wednesday. All right, guys, all the best. I will see you then. Cheers.